Today, at the University of Aveiro, a journey back to indigenous times begins, where the traditional use of smoke has always been a fundamental human need. At the Department of Environment and Planning, this concept is integrated into a subsonic wind tunnel facility, which lacks any smoke visualization system, prompting the creation of this project to enable flow analysis. The first milestone was the development of a smoke line generator for wind tunnel applications. The second was the adaptation of the generator into a system for generating segmented smoke lines. For the continuous smoke line generator, the geometry utilized a symmetric NACA 0012 profile. The inner volume was reduced by a factor of 0.25, leaving minimal space between the manifold wall and the outlets, to guarantee maximum mass flow uniformity. For the segmented system, the exact same NACA 0012 aerodynamic profile was maintained as the baseline design, adapting the structural layout to house the flow mechanism. Numerical boundary conditions were established in ANSYS Fluent, defining the wind tunnel air inlet, the smoke tracer inlet, the pressure outlet, and the remaining solid walls. A rigorous mesh generation process was performed, ensuring a mesh-independent study and a highly structured refinement near the injector walls to capture severe boundary layer effects. Inside the setup, gravity and room temperature were defined, while species transport equations managed the distinct molar masses and chemical properties of air and smoke. The numerical particle tracking for the continuous smoke line generator predicted a highly uniform mass flow rate across all front injectors. For the segmented system, the transient numerical simulation successfully demonstrated the controlled behavior and synchronization required to generate distinct tracer lines. To avoid thermal warping in the 3D printed PLA prototype, a commercial LEANDRO cold smoke generator was integrated for the experimental phase. The experimental validation of the continuous smoke line generator proved to be highly successful. The simulation was well conducted, demonstrating an elevated similarity between the CFD flow behavior and the real-life tunnel testing. The segmented smoke line adaptation also showed excellent results. The transient numerical model was fully validated by the physical testing, proving to be well conducted due to the precise structural correlation between reality and simulation. Ultimately, the development of the continuous smoke line generator was achieved, and the adaptation into a system for segmented lines was fully validated. This project provides a robust, low-cost tool for aerodynamic diagnostics at the University of Aveiro.